Hey guys, welcome back to another video, and today we're going to be working more with triangles, and it's going to be a little more in depth, and we're going to be introduced to like inverse trig, just very basic because we're not working in the unit circle, so it's more so of a tool for us to use to find an angle and we have all the sides and just continue to solve for triangles. Now, the reason why I've been delaying the unit circle for a little bit is because we're working in the world of triangles so far, so it's only things from like 0 to 90. So the unit circle is much more than that. It's about like rotations, negative angles, and triangles can have a negative length. So that's why I've been staying away from that. But as you'll see, really trigonometry is all about triangles. So when we get to the unit circle, what we're doing now will benefit us in a way. Okay, so anyway, let's start off with this example. So this problem gives us an angle. It says theta equals 32 degrees and tells us to find all sides and angles. Right away, I can tell from the get-go that, well, we're missing this, let's call this x, and we're missing this, let's call this y, and we're missing angle, let's call this a beta. Okay? Now, the reason why I was very, very like niche with what I was saying about these two angles x and y is because we've learned in geometry class, we call it adjacent, or we call this like opposite. The thing is, it's very subjective here because since we have, remember, a triangle has 3 angles and 3 sides. The y is the opposite of theta, but it's the adjacent of beta. So that's why you have to be a little more, like, when it comes to the opposite and adjacent sides, you have to be a little careful. For hypotenuse, it doesn't matter because they both share the same hypotenuse. Always like that. With anything related to triangles or unit circle in general, the hypotenuse, the radius, which is the same thing, both angles share the same hypotenuse. So let's do this. The first thing I want to do is there's a few ways we can approach this problem. We do have theta, and we're missing beta. We can go ahead and we can solve for beta. So how would we go about doing that? Well, here's this formula. So anytime we're working with triangles, you can do the formula. It's 180 degrees minus 90, parentheses 90 is this angle right here, 90 degrees, you always have it, plus the angle that you already have, which is a 32 degrees. So if you compute this, 180, you get that beta equals 58 degrees. Okay, good. So now we solved for an angle. So now we have all 3 angles. We have always our hypotenuse always given, which is 90, in a right triangle at least. We have theta, which was already given, and we have a beta. And we can check this because if we add up 58 plus 32, we get 90, so we're correct. That's how you can always check. So now let's go ahead and let's solve for y. Let's go ahead and solve for y. So in the other problem, we were only solving for one side, but recall that if you have at least one angle, in one side, you can solve for everything. But when you have an angle theta, if theta and beta both here were unknown, I'd at least need to have known all the sides, not just the one they gave us, which was the 20, the hypotenuse. I'd have to know all the sides. So I need to have at least 2 sides, and I can solve for the other using the Pythagorean theorem. Now, why is this relevant? Why am I talking about this right now? Because what you'll see later in the next, we'll be working with something called inverse trig. An inverse trig is a tool that allows you to solve for theta when you don't know what it is, but you have all the sides. But I'll get into that a little later, but let's go ahead and solve for y. So we can use either one. We can use beta, we can use theta, like in regards to it, to solve for y. So let's use theta because we're used to that. So theta, y is opposite of our theta, and we have our hypotenuse. So that means we can do sine of a theta equals y divided by 20, and we can use a theta as 32 degrees, So sine of 32 degrees equals y divided by 20. Now we can rearrange and solve for y. So 20 sine of 32 degrees equals y. So this would be our y, which would go out to be sine of 32, which is 10. So y is approximately, 10.598. This is a 10, not a plus. Okay. Now you could go ahead and use Pythagorean theorem here, but it's going to be a right answer, but it won't be exact. So let's go ahead and let's do the same thing for x now. So let's use beta this time for a new perspective. So beta is again opposite, and we can use our hypotenuse. Usually I'd recommend not using the decimal form. Like we can go ahead and we could have done the adjacent over hypotenuse in regards to angle B, because now we have y, but I would recommend just going with the original problem, but that should be right, but it's going to be not as exact. So again, let's do sine of a beta equals x divided by 20. And we can input a placeholder. B is a placeholder so far, so it's 58 degrees equals x divided by 20. Go ahead and solve for x. So x equals 20 sine of 58 degrees. Now this should be an acceptable answer. This is correct, but if you want to like sing round or whatever, again decimal form, since anything that's not in a unit circle, which we'll get into more depth later, you need a calculator to do, because you don't know what that is. You have to know what the angle is. So sine 58 degrees times 20 is 16.9. So x equals 16.96. So that's it. That's everything. That's how you do the problem. It's pretty straightforward. It's it's basically the same thing as the last as yesterday's video, but we just solved for everything in the problem. We solved for the two other sides that were missing and the one angle that was missing, and we just include this formula. So the formula that you always want to use, you want to find the angle, it would be 180 degrees minus 90 degrees, which is always given, plus, if you have at least one angle, remember we had theta 32 degrees, and you should get your other angle. You could do 90 minus that angle because they're all going to equal 90 because they're complementary, but this is something I learned, so I know this works. So if you want, you just have to know that both angles that you get have to add to 90. So that's how you do this problem. So now we're going to talk about inverse trig. So now we have a problem that we have to do, and it says find angles and sides. Now, in the last example, we said something about, let's say we had beta. Beta equal 180 degrees minus 90, which is always given degrees, plus a theta. Or, the other way you do it is it'd be 90 degrees equals theta plus beta, have to equal 90 degrees. Now, whatever formula you decide to use here, it starts to be a problem. In algebra, you can't have two unknowns without doing systems of equations. And if we were to do systems of equations for either one of these, there's an infinite amount of possibilities that can give us 90 degrees. Let's look at the second one. 45 plus 45 gives us 90 degrees. 30 plus 60 can give us 90 degrees. 20 plus 70 can give us 90 degrees. So we're not going to get anywhere. So for theta and beta, we don't know what they can be unless we use something that's called inverse trig, or arc. They're abbreviated as arc sine, arc tangent, arc cosine. So the inverse trig only exists for tangent, cosine, and sine. So what have we been working with? In the first video, we talked about that if we have something like cosine of theta equals y. So theta is an input. It's like a function. It's the same idea as f of x equals y. Same idea. So whatever angle we plug into the function, we get a y value. The thing is, there's a way that we can get that specific input, and it's called something called inverse functions. Especially for this when we work with inverse trig. So if cosine of theta equals y, okay, cosine inverse of y equals a theta. We can go ahead here, since we can solve for all the sides, and we can use any trig ratio we want, and we can get the angle that will give us that two ratios of sides, or the ratio of sides. So that's what we're going to do here. First thing let's do is let's first solve for our hypotenuse. So we know that a squared, because for this, they need to give you all the sides to be able to do this. A squared plus b squared equals c squared. And this is also, it happens to be one of the things that it's one of the sides that we need to find. So if we do, a and b don't matter, it's only c that matters because c is the hypotenuse. So 8.7 squared plus 11.2 squared equals c squared. So c equals 8.7 squared plus 11.2 squared. I'm not doing addition of square roots. That's not allowed. I'm just like showing this, like I'm like skipping some steps. So if we do 8.7 squared, we get, is still new in the under the square root, 75.69, and 11.2 squared is 125.44, and if we go and add these up, so c equals the square root of 201.13. So c equals 14.182 approximately. Technically, we didn't really need it. We could have like just used the two that he gave us, but we need to find it anyways. So let's go ahead and let's find theta and beta. So the opposite of theta is 11.2, and the hypotenuse, which was now x, is 14.182. But like I said in the last, let's use something that allows us to use the things that were given in the original because it's more safe that way. But it doesn't really matter. So let's go ahead and switch my mind up. Let's do beta. So if we had, which was already given the problem, so beta, opposite of beta is 8.7, and adjacent of beta is 11.2. So let's use tangent. So tangent of beta, you know what beta is 8.7 divided by 11.2. If we do inverse tangent, 8.7 divided by 11.2 will give us beta. So let's simplify 8.7 divided by 11.2. So we can do, and by the way, if you need to do this, you could just, there's an inverse tangent or it's arctangent on your calculator. So 8.7 divided by 11.2. So that means we put this in the calculator because we don't know what this angle is. So B equals 37.84 approximately degrees. Make sure your calculator is in degrees, by the way. So now that we found beta, we can go ahead and use our formula right here. Remember? But we can do it in theta equals 180 degrees minus 90 plus 37.84 degrees. So 90 plus 37.8, which is 127.84. So that means theta equals 52.16 degrees. Now, well, why didn't I do the same thing for theta? I could have done the same thing, but remember, in the same problem, the other problem, if we know one angle, well, if we know technically, if we know two angles, which is the right, which is always given, and the other one, we can just do one, we can just use this formula. And if we make sure, if we do 52.16 plus 37.84, they should add up to 90, which they do. So that means our angle is correct, and that's really it, really. Just a little background. So if you have, just to like explain a little more, if you have something like cosine of theta equals like 7/4, and you want to know what angle that you put into here will give you this, you can just do cosine inverse of 7/4, and you'll get that angle. And that's what we call inverse function. You can do this with tangent, sine, cosine, but you can do this with a triangle, whatever. It's a really useful tool. But once you get into unit circle, it starts to get a little more complicated because you have to work with domain restrictions. But just for triangles themselves and things that are in unit circle, using the calculator will really help you out. So that's really how you do it. It's a little just a continuation on the last video, and in the next video we're gonna finally get into the unit circle because there's not really much left for us to do with triangles here, except for application problems. But I really want to get into unit circle because that's going to be the guide for all the other things in trig. So hope that this helped, and have a great day.